Sa video natin ngayon, I will discuss some of the problems that most students found difficult kanina. Now for the first one, we have the wooden floor system which consists of floor joists. Itong mga naka-blue, ito yung joists or simply yung beams natin. And the new spacing is 0.2 meters on centers. This is the spacing. This is the first joist and then ito yung second joist. Yung distance between the two, that's 0.2 meters. And then supported daw siya by girders dito sa gilid, itong naka-green, saka ito rin sa kabilang side. And then the span of the joist is 2.2 meters. Ito yung length ng beam from this point up to this point, in which we'll consider this as a simple support. Now the tongue and groove floor is 25 mm thick, and then if wood weighs 5.5 kN per m cubed and the live load is 2.9 kPa, we have to compute now the maximum moment on each joist produced by the live load and the weight of the flooring. And then we'll just assume that these are simple supports, this one and this one. That's provided by the girder. Now yung load sa beam natin are caused by the following. First, we have the weight ng wood and we also have the live load. And so what we want is to get the load W na nag-a-act dito sa joist natin. And so, if you will isolate this joist, magiging ganito yan. This is 2.2 meters, yung span ng joist natin, and then we have simple supports which are provided by this point and this point. And then we need to find the load W that's uniformly distributed. So this is W. So this W is due to the weight of the wood as well as the live load. So diba, since this is our tributary area, dyan mag-a-act yung live load natin. And so if I am to draw the loads in red, ito yung live load natin. Yan. Ito yung live load. Let's just make this parallel. This is our live load. And so, yung mangyayari, diba, if this is 0.2 from here up to here, then this is half of 0.2 and this is also half of 0.2. So this is 0.1 and this is also 0.1. So yung total nito, that's still 0.2 meters. Now this is force acting over an area kasi diba yung unit ng live load is kPa or simply that's kilonewton per m squared. And so to convert this into a uniformly distributed load over this span, we need to multiply the live load by the spacing. Kasi if we will multiply this by the spacing, this dimension, we can get the load that acts dito sa center. So I repeat, if we'll multiply this by the spacing, we can get the equivalent load dito sa gitna. And so this is what we want. And so we have the live load which is, let's just write this as W in kN per m. First, we have for the live load. So this will be 2.9 kPa or kN per m squared multiplied by the spacing. So this is times 0.2 meters or simply this dimension. So this now becomes 2.9 times 0.2, this is 0.58. So 0.58, and then diba, magka-cancel yung m dito, and then we are left with 1 m dito. So this now becomes kN per m, which is the unit that we want. Now for the next one, we have the unit weight of the wood. So this is due to weight. Now diba, we are given the unit weight which is 5.5 kN per m cubed. And so what dimension will multiply dito to get kN per m? Diba, we need to multiply this by m squared so that this will cancel and then we are left with kN per m. And so yung tanong is, Sir, ano yung area na imumultiply namin dito? Yung imumultiply natin na area is the cross-section of the slab. Now diba, yung cross-section nito, yung imumultiply natin is the cross-section of this span. But we are essentially considering this cross-sectional area. And so if ito-draw natin to in 3D, we have this figure. Yan. Itong drawing na to, it's this part. Yan. And so diba, we are given the floor thickness which is 25 mm. So this is 25 mm. And the diba, alam natin yung spacing which is 0.2 meters. So this is 0.2 meters. And so the cross section which is this area is simply 25 mm which is in meters 0.025 multiplied by 0.2 meters. Yang area na yan. And so we need to multiply this by 0.025 meters times 0.2 meters. So this is now 5.5 times 0.025 times 0.2. We have 0.0275. And then this is kilonewton per meter. And so adding both, we have, let's move this. This is now 0.58 plus 0.0275 kilonewton per meter. So plus 0.58, this is 0.6075. And then we have kilonewton per meter. And so since we already have the load, then diba, we are required to find the maximum moment. So for each joist, the maximum moment, since we have a uniformly distributed load, Mmax is equal to yung general formula natin, WL squared divided by 8. And so this is 0.6075 multiplied by the length, which is 2.2, and then squared divided by 8. So this is 0.3675. And then this is kilonewton meter. And so our answer is letter B.